Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, well, welcome everyone. Today we have with us Sergei, who's one of the creators of Testcontainers. And I've been a huge fan of Testcontainers since I started using it a couple years ago. And I think that I was just starting to use it when I first met you in person. Maybe the only time I met you in person, which was at Devox Belgium in 2019. So one of the last conferences that we probably went to. And so anyways, it's great to have you on. I am a huge fan of Testcontainers, and so I wanted to have you to chat about that.
And Sergei, do you not know how to pronounce his last name, or you just...
I don't even know his last name.
What is your last name, Sergei?
Egorov.
Egorov.
Yeah. Oh, okay. That's pretty good. Yeah.
Okay. Well, I was imagining the spelling in my head.
Yeah.
So I was trying to...
It's so funny because I don't know. I just don't even know most people's last names that we have on the podcast. There's a lot of times I have to go look up their last names when I create the episodes.
Okay.
Yeah.
Well,
I just know people by their first name.
You're a first name kind of guy. Okay. So I'm going to... James has talked about test containers, and I go, it's probably not something that applies to me. So I have never, what problem are you solving with test containers? What's the pain point?
So straight to the main section. I like it. And first of all, thanks for having me. Really, really happy to be here. And yesterday, James was on our live show, so it's great to have this conversation back and talk a little bit about more of the basics of test containers.
Mm-hmm. Now we get to hear. Yesterday, I talked a lot. Now we get to hear from you today. Really great.
Sounds good to me. I'm the talking guy. So, first of all, I'm Sergei, one of Testcontainers team members, and I've been with Testcontainers for the past almost 6 years. I've been saying 5 years, but now we're getting closer to 6.
I didn't realize Testcontainers has existed that long.
Yeah, it started in 2000.
I feel like I'm late into the game. The fact that I've only been using it a couple of years, it's usually I'm bleeding edge, but it turns out no, I was not even close to bleeding edge.
Yeah. But you managed to catch up with everything in the Testcontainers community very fast, and then created your own movements, I would say, but we can talk about it later. Yeah. But Testcontainers was created in 2015 by Richard Norris, who is also a co-founder of the company we are in right now, AtomicJar, the company behind Testcontainers. But he created it to solve his own problem he was having while at Deloitte Digital. He needed to solve a problem of integration testing, because that's what they were doing at his team. And they were doing consulting for others. So we're working on many projects, but all these projects share the same problem. How do we test the software that we ship? Because you have two options. Option number one, you test in production, aka no testing. You just ship it, and then you keep your fingers crossed that everything will be working correctly. You have to be, you have to be genius to write code that works from the first attempt, and I don't think anyone in the world can do that. So
based on the number of updates I get on my phone for apps that say bug fixes and performance improvements, I'm guessing that most people don't get production right the first time, or the second time, or the 100th time.
When you say integration testing, you mean, okay, we have the software, we think it works, and now we're going to make sure that it actually works in something similar to the production environment? Is that integration testing? Or
I guess the biggest point,
features, or what?
I guess the biggest point here is that since we have the stages or levels of testing, we can do unit testing where we just test our code and nothing but code, and then we make a lot of assumptions about things and how they work, especially when we talk about modern microservices. That usually what they do, they just take some data from a database, run some transformations, and return it as JSON to some HTTP endpoint, or send it to Kafka. And since we're talking about some thin wrappers around the data, we need to make sure that we properly test it, because yes, we can unit test some transformations, like how we turn this object into some DTO. We can unit test it because that's all code. But it's a bit challenging to unit test external dependencies. Like, for example, how do we test that Postgres would execute this query correctly. We cannot just say that if I send this text to the database, then I will always get this response, because that's an assumption.
Yeah.
And getting rid of assumptions is the best way to improve your testing. Like, the less assumptions you have in your test, the better. Like, you cannot assume that database will always return this result, nor you can assume that it will return it in a timely manner. For example, like sometimes it takes longer to execute queries, and so on and so forth. And
so let me frame this in another way, which will be relevant to our book. So we're writing a book about effect-oriented programming, and in this model we have pure functions, and then we have effectful functions. And so your pure functions can be tested entirely with unit tests because there's no external dependencies because they're pure. Your effectful functions can only, well, you could either create mock services for the effect parts of it, but that's not actually testing that the effect actually works against the external service.
Right.
And so the integration test would be to plug in your live service into your effectful functions, and that would be the integration test. Would be when you actually use the live service.
And so, databases are typically mutable, so
they are typically yeah.
Otherwise, you could just write a function to represent the database.
Could you write a function? Yeah, exactly. So your integration tests are the effectful, testing the effectful pieces. Like, you could write an integration test against a random service that actually would test that your random is valid.
All right. Okay, I think that's clear.
Yeah, I like this analogy with pure functions, actually, because that's indeed the case. Like, you cannot assume side effects. You need to bring them to make sure that your pure functions, your code is tested correctly.
Yeah.
Unless it's composed of pure functions only, but it isn't the case sometimes, or most of the times with modern
services. I've
services.
never seen any useful system that was only pure functions.
Me neither.
Bitcoin mining. Nothing goes in.
Isn't there a distributed aspect of Bitcoin?
Yeah, interesting. I'll have to noodle that one a little bit.
And that's it. We jump onto Web3 discussions, right?
That's right.
So NFTs, let's mine some tests.
Yeah. Okay, so we've got our integration tests, and Richard, one of the other co-creators of Testcontainers, or maybe the initial creator of Testcontainers, he was not happy with how integration tests were. Something about integration tests. So then what happened?
Back then in 2015, Docker wasn't something that's deployed to the majority of production systems, but rather something new and emerging. And while there wasn't, this widespread readiness to have Docker in production, people started realizing that Docker is overall a great idea and a great technology, and starting adopting it more and more in various areas. And for Richard, this area was integration testing, because he was lacking this abstraction for running integration tests. Before Testcontainers, before Docker, you had to set up local testing environments yourself, like manually, and then you had to do the same on your CI systems. And then you submit this Jira ticket asking for your sysadmin to create or to configure Postgres on Jenkins node ABC. 1 month later, you get it configured, and you're already migrating to the next version of Postgres. So you submit the new ticket asking that, could you please update Postgres to that version? 1 month later, and you get a 1 minute. So
having consistency across your local dev, your CI, and your production was a significant challenge that most people just said, too hard.
Yeah,
okay,
that doesn't scale well.
Yeah.
Okay.
Mm-hmm. And with Docker, that's a different story. You just need to ask someone to provide Docker. As long as you have Docker, you're good to go. And Docker is a great abstraction, but it is an abstraction. It's not as low level as using, jails or some other containerization technologies, LXC and others. But then it's still an abstraction. And as it happens with abstractions, we create more abstractions on top of abstractions. And that was his idea. Why don't we create an abstraction on top of Docker for testing? And since he was a developer with a developer mindset, and he'd been also pretty advanced when it comes to running things, but also writing tests and creating them, he realized that the most flexible way would be to create these databases, brokers, and what's not directly from tests, because Docker exposes an API. Then we can talk to HTTP API from Java. So why do we need a CLI? Why do we need Docker Compose, or back then Fig? And why do we need all these other technologies if we can talk directly to Docker? Because then we gain a lot of flexibility. We are starting to do this imperative approach, like programmatic approach to creating test environments versus having something declarative where we would describe our ideal test environment and start it. And then you need a separate tool to start before your test, stop after the test. Then if you need, let's say, a database per test, you start wondering, how do I do that? While with programmatic approach, it's up to you when, how, and what to start. And that's test containers, basically. That's your interface to Docker for testing that removes or like adds additional abstraction on top of Docker and makes you care less about what's going on under the hood and makes it as simple as having Docker available.
Yeah. Is that
so you're adapting Docker to be the test container? Is that what it is? This is on top of Docker?
On top of Docker.
On top of Docker.
Yeah.
But so from my standpoint as, okay, I'm the application I'm running inside of Docker. I want to I want to interact with the database. So what I'm interacting with is the test container that looks like the database.
Is actually the database.
It is the database,
Yeah.
but what's it doing? Is it connected to the real database, or is it just cloned the real database so that it can behave like it?
The thing is, it is an instance of the same database technologies that you're running in production, because now that we have Docker and all these images such as Kafka, Postgres, Oracle, DB2, and others, we can actually start an ephemeral instance of our database that we use in production, but locally. Not exactly the same way. We don't need to start large clusters of Oracle instances just if we need to query something simple from them. We can start as simple as just a single instance, as long as we are running the same thing. Not something that quacks and do other things as my production database. So, for example, one could say that, hey, why do we need Postgres? I could just run H2 in Postgres compatibility mode, right? And while that applies to 90% of usages, you'll always be hitting this remaining 10% implementation details, because as it
I
happens
seem to run
with
into
everything.
this every single time. Like if you frame it as a 90% problem or a 10% problem, where like when I use Postgres, I'm always like adding in like the GIS module, or adding in some module into Postgres, into my Postgres database. And of course H2 doesn't understand those Postgres extensions. And so I like every time or like I use the JSON-B support in Postgres, and so of course H2 doesn't like understand Postgres JSON-B support, or whatever it may be. But it seemed like every time, like for me, it wasn't 10% of the time. It was every time I wasn't able to use H2 as an accurate alternative to Postgres.
So the test container somehow clones the database.
It doesn't clone. It just is the Docker container for Postgres. So all of the major backing services like Postgres, Kafka, whatever, they all have Docker containers. And so you can spin those up on your local machine or in your CI environment and get a database, but you still need to populate it with your schema if it's a database, and populate it with test data, that sort of thing.
And you're saying any add-ons that you put into the database.
Yeah.
But is that part of the configuration for the test container to do that?
Extensions? Is there a way with the Postgres container, test container, to add Postgres extensions in? Actually, I haven't done that.
We don't have this programmatic API for that, but since we are operating on abstraction of Docker images, you can build your own Docker image that would include all the extensions that you need. or you could do it at runtime. When you start the containers, then you deploy extensions to the running container, because you have
Actually,
an
I think I
actual
have
instance
done
of
this, and I did
Postgres.
it through just like in test containers, you can run a set of bash commands
Mm-hmm.
after the container is started, right? And so then that allows you to add in the extensions that you may want. So
And
I think
I'm
I did do this.
assuming it's keeping this thing running throughout your whole local testing process. So if you made a change, it wouldn't have to spin it up again. Is that right?
So
Or
part of the cool thing about test containers is that it moves the lifecycle management into your development workflow and into your code versus it being an external thing. So if you were building a database application, the traditional way that you would do it is you would install your database on your machine, you would start it up, and then you're fully responsible for managing the lifecycle. There may be times where you have to like blow it away and start it back up. And in the case of test containers, that whole lifecycle is managed by your code and your program.
so you configure how it's going to.
That's right.
Whether it's going to blow it away for every test or whether it's going to keep it.
That's right.
There. Okay.
Yeah, so the lifecycle management moves into your project versus it being an external thing.
Mm-hmm. And we also have some components in test containers that will make sure that you never leave anything behind your test run. Or after your test run, meaning that, let's say, for testing, I would argue that the most important thing isn't even starting things, but rather destroying them. And it's especially important for CI environments, because there are so many ways how things may go wrong. Like your CI executor may crash. And then if you have an external abstraction, such as Docker, you may end up having dangling containers, like containers that are no longer owned by anyone, yet are still running. And then you'll see a degraded performance of your CI environments, and you'll be wondering what happened. And apparently someone just killed a job on Jenkins, and then when you kill a job, then it will receive a kill 9 signal, meaning that your GVM, for example, won't even attempt to run shutdown hooks.
Yeah.
And that's how we initially implemented cleanup mechanism in test containers, and ended up getting requests or like reports by our users that, hey, apparently I have some dangling containers. Yeah. And we start thinking like, what can we do about it? Because yes, we are part of the test run, which is an advantage, and in a way a disadvantage, because we have no control of what's going on outside of the test lifecycle, or a test session lifecycle, outside of the GVM that runs the test. And we need to somehow control it even beyond the test run. We want to make sure that even if something happened to the test machine or test GVM, then we would still destroy the containers. This is how we ended up adding a component that's called Ryuk to test containers.
I've seen the Ryuk container running, and so I have questions about that. But yeah, go on.
It's a very geeky thing, and I'll explain the naming in a second. But the point of that container is to record every container that we start. And as I said, it's a container. So it's not part of the GVM process, but something that we start because we already have access to the container technology. And then we record everything we start, and then we maintain a persistent connection between the test session and that container. And if the connection drops, and if it never gets reinstantiated, we detect that something happened to the test host, and we start destroying every resource that got recorded to that container. So that
so it's pretty cool. There's this container that runs and is the coordinator of the application and what it's doing, and the dependency containers that it is managing for that like test session. So that's what the Ryuk piece. And so it's keeping track of the state, keeping track of the connection liveness, and then if you actually like are watching your Docker containers to see what's running, you'll see the Ryuk process running, and then you'll see as you run your tests, your Postgres container spins up, your Kafka container spins up, whatever, and then as soon as your test stops, Ryuk then goes and shuts all those down.
So the unreliability of the network is a feature in this case. That's what you use to queue
to know.
You go, okay, we don't know anything now.
Connection's gone.
Connection's lost, so we're just going to assume they either decided to shut down, or they wanted to shut down, or something went wrong. So we're just going to shut everything down and make sure cleanup happens.
Yeah.
That's fascinating.
So a big part of test containers is that like resource management of all of the underlying containers that you need. And a really cool thing that you can do with test containers is because test containers is managing not just the life cycle of the container, but also managing the configuration of the container. So for example, usually when you run, we keep using Postgres as an example. That's a good one.
Fine.
But usually when you start up your Postgres server, it runs on port 5432. Is that right? 5432. Yep. And so you can only use that port once. And so let's say you wanted to run multiple Postgres instances in parallel, that becomes challenging. You have to like go figure out how to like change the port. Well, test containers can just say, all right, you run on this port, you run on this port, you run on this port. And so it's controlling all the ports and the port mappings and giving your test that information about what port things are running on so that your application doesn't care. And Ryuk and test containers have managed it. And so if you want to run things in parallel, you can.
Yeah, the number of the port and where the port is a level of abstraction that's inappropriate.
Exactly.
To have to deal with.
Yep. And one could ask, why don't you call it Watchdog? And I wish you asked this question when we were considering the naming for this component, because it's a totally appropriate name. It is a watchdog, and you will find watchdogs in many other systems. But somehow that didn't come to our minds. But it was a great suggestion by Richard, and we are geeks here in our Test Containers core team that consists of Richard, Kevin Wittek, and myself. And Richard suggested, and his question was like, have you watched Death Note? And that's a manga, like popular manga, like one of the most popular ones, I believe. And the point is that, I mean, it's, as I said, it's very geeky, but the point is that there was Death Note, and then every name that gets recorded in Death Note, like that person will eventually, like something will happen to them. He'll either like die or get killed. But like eventually he will be terminated.
Okay.
And Ryuk was the god of death. So like that one who will be executing.
Wow.
And yes, as I said,
that's
very
where the
geeky,
name came
but
from for Ryuk.
Yes, the analogy was so good because that's exactly what we are doing. We're just recording all these containers to the Death Note, and then eventually we like there's like it's guaranteed that they will be killed. And I'm talking about containers, so I can use this word, but it's a bit of like hard wording for this abstraction. But on the other hand, it was fun, and as I said, we are geeks, so we're still having some fun internally. Implementations.
And that the Ryuk node, that container that runs, that because it runs in a container has a bunch of logic in it, and it's reusable across test containers for JVM versus Go versus Node versus whatever, because test containers can be used. Python how's the Python modules for test containers?
It's one of the earliest alternative versions of test containers. So we started with Java, or Richard started with Java, but then test containers Python got created. Test containers Golang, test containers Node.js, test containers Rust, even Haskell. We have test containers Haskell created by some community member, but that's a cool thing. And this is how README for test containers Golang starts. One of our users, he was enjoying the Java version, but then he started working on a Golang code base, and he was lacking this experience of running tests with test containers. So what he did, he ported the ideas from test containers Java to Golang language, and then that's how test containers Golang got created. Now it's second most popular version of test containers after the Java version.
Wow, cool. But it's cool that the Ryuk piece can be reused across all those, and so you don't have to rewrite that since itself it runs in a container, which is portable.
And it is very lightweight. We were using Golang to implement it so that we aren't adding overhead to the set of containers that are being started, because we understand that not everyone will have Docker with 16 gigs of RAM. Some would run it on Mac, on Windows. They would allocate 4 gigs of RAM for everything. And considering these limitations, we wanted to make sure that we aren't starting, let's say, a Java process that requires some memory to start, which is fine because then we get awesome performance. But where performance isn't that needed, we could also go for something more lightweight. Now we have GraalVM, so it would be easier.
Yeah, I was just gonna say you've got Oleg working there. So Oleg used to work at Oracle on GraalVM native image and GraalVM stuff. But hey, we should try to rewrite this in Kotlin and with GraalVM native image. So
I'm sure I would understand it then.
Yeah.
Nice. So, and the company, how long is the company, and what's it called again?
So AtomicJar is a company we started earlier this year in March, actually. Okay. And we closed our seed round in June. And we've been working on our product for Testcontainers users. And we just announced the private beta of Testcontainers Cloud, which is basically the managed version of the same experience. So instead of running your containers on your local Docker or Docker available in your CI environment, you would just run it on a remotely available environment that we start on demand. So it's like, sorry, I'm dropping some buzzwords here, but it's similar to serverless approach to integration testing. There is no server to think about because Docker is a server component, and not everyone feels comfortable about running Docker in their CI environments, for example, or even locally, or sometimes they simply cannot. Like, let's say, when I started prototyping our product exactly 1 year ago, which is funny because it was exactly 17th of December when nice. I had my Hello World commit. I had Apple M1
stuff.
Yes. Yeah. I got myself an Apple M1 machine, and it's ARM based, and it's super cool. It's super fast. But then I realized that I cannot run my own tests. Like
a year ago, there wasn't M1 support for Docker yet, and so you couldn't run Docker on your brand new M1 Mac. And so
yes, that was a bummer. And ever since then, I was very motivated to get Testcontainers Cloud running, an MVP of it, just so that I can run my own tests.
Nice.
Well, yeah. So you guys decided, and there's 3 of you in the company.
10 of us.
Yeah,
there's 10. Okay. And when you started it, before you went and got investment, how many were there?
So the thing is, our team kind of like Richard, Kevin, and I, we've been working together for the past. So I've been working with Richard for the past 5 years. Kevin joined us around 4 years ago, and we've been always collaborating on Testcontainers in our spare time. And we were always
your hobby was working on Testcontainers.
Yes. So we were always working together, but not like a company, but rather just like on some spare time, we do some things. And when more than 1 year ago, I decided to explore new opportunities because I've been Pivotal, and Pivotal got acquired by VMware, and VMware was too big for me. So I started thinking what would be the next thing for me. I got approached by some of Testcontainers users, and he told us that he's running his business, and they migrated the whole company to Testcontainers. They're so happy with it. They see the value. And he's also an angel investor. And he asked me, like, hey, instead of trying to find a new job, don't you want to start your own company? I was like, that's an interesting idea. Let's talk. And then I shared some of the product ideas we had, because we have a few, but obviously we need to start with one. And it got him excited. This is how we ended up thinking about the company. And later, I instantly communicated to the rest of the core maintainers team. But then we ended up co-founding the team together with Richard. And Kevin joined us as an engineer once we closed our seed round. And then we started hiring from our existing community of Testcontainers users. So every single team member, every single engineer on our team, they've been using Testcontainers. And there was also a funny story when one of our non-engineering team members, she learned that her landlord, he is a user of Testcontainers.
No way.
Just imagine talking to your landlord and mentioning that you're working for a company behind Testcontainers. You're like, oh, wow, I know this technology. I'm using it. Crazy.
That's wild. Huh. So Go ahead.
Okay, so did you start with the angel investor? Is that what happened? And
We
then
considered starting small, but
yeah.
then got some traction, got some introductions, and ended up like we initially were thinking about small check from an angel investor.
Hmm.
Then we decided we want to go VC round, and we thought like, okay, raising $1 million would be incredibly cool because like that's $1 million
Sounds like a
idea,
lot of
right?
money,
Yeah.
right?
Yes, that's a lot of money,
And the angel
indeed.
investor said, "No, no, go for 10 million or something like that."
No, it wasn't. It wasn't his call, but rather us talking to more and more people, and eventually we were asked, "Why so little? What? Like
That's yeah,
it
that's a
isn't.
lot.
It isn't
It's not
small
a lot.
amount. Like,
Yeah.
but I made a good point that we have something big here, and like to implement something big, you need a decent investment, and this is how we ended up closing our seed round of $4 million,
Mhm.
and we got very lucky because thanks to our network, thanks to introductions, we were able to get in contact with Boatstart, our lead investor, who were just named the best seed investor just in general, not only in DevTools, but in general, which is
Mhm.
kind of cool.
Yeah.
But I can definitely say that they are really, really good because our initial thinking about VC companies was somehow affected by public opinions about them, right? Like everyone would tell you that if you go the VC route, then you always be pushed for, like increment your revenue or like increase your revenue, just, like, I don't know,
Yeah,
you
that
know,
there are some
all these
significant
stories.
downsides to
I've
taking
gone through the
VC.
whole process myself of initially going, oh, the vulture capitalists and all
Vulture
that kind of
capitalists. I haven't
stuff.
heard
Yeah.
that.
Oh, yeah. They're just in it. And then eventually you begin to realize, oh, well, but these are different, they're just companies and they're different groups of people and they all have their own characteristics. And you have to find one that is a good fit for you.
To
And
Mhm.
those
lump
are,
them all
and
into
well, right, rather than
the
just go, oh, I have some money, I'll put it in there and then I'll annoy you about you're not making my money back
Mhm.
fast enough. And you have to understand, it's like, well, they're investing, and if they're lucky, if they're good at what they do, they might get 1 in 10, and the other 9 are going to be failures, and there's all this,
Mhm.
and then you begin to understand, and you go, oh, a good VC is what you want. You don't want the one that necessarily offers the most money or anything. You want the one that works with you and helps you, and is, you know, shepherding you to success. And
Yes.
then it's a whole different way of thinking about it. And you
yeah.
go, oh,
It can be
that is
something that
valuable.
really helps you
Well,
versus
that's what you want.
yeah.
That's what you
Mhm.
Yeah.
want. You don't just yeah. Anyway.
Yeah.
Well,
I
how
would
cool
say
is it
my
that you were able to find, I think, a real product and business
Mhm.
model around test containers that existed. Like I've spent a lot of my time working on WebJars, which I think you're familiar with
Mhm.
WebJars,
Of
and it's a
course.
fun hobby and all that. And I've been asked a few times, like, oh, could you like create a business around WebJars? And I'm like, I can't think of any like legitimate business model around this open source project. But test containers, it seems like there's some pretty good and pretty
Yeah.
obvious like real viable business models
And so
around, which is
what
cool.
is is it the service in the cloud that you pay for? Is that the business model?
So yes, it's the model where you would pay for the execution of your tasks. And by the way, if you're not running your tasks, aren't paying for anything, which is great because we understand that, especially for developers, like some may just like run tests one per week because that's how they develop, while others they would be running like tests every hour or like every minute because they're very active with that.
Serverless
And
integration tests.
Mm.
That's
mhm,
Hmm.
mhm.
yeah.
Yeah, and
But I would think also that people would maybe want consulting.
that's something we've been considering even like some years before we even started the company because we noticed a lot of traction going on. Like test containers started growing very fast, and like a lot of companies, a lot of integrations. Like it eventually became the go-to solution for testing. That is also advertised by biggest frameworks out there, like Spring, for example. They were recommending test containers. Red Hat and their products, they were also, or their projects, they were also recommending test containers. And when you get that level of traction, you start noticing that, okay, like there is an opportunity. But the thing with consulting, for example, and that's another way of starting a company. You could bootstrap it and then start selling consulting, maybe building some products on your spare time between the consulting gigs. But it takes a lot of effort and it doesn't scale well, especially when you have a topic that is very specific, like especially when you create a new category of something. And while for a big company, it makes some sense to start selling support for their projects. Selling software nowadays, so one thing is support. Another idea is to sell software, like creating something like Testcontainers Pro. And while if you're a big company, it makes sense. Like let's say if Testcontainers was a project by VMware, Red Hat, and others, then you would of course expect to see a commercial offering of the project itself. But when you're starting
like
as
open core model, where the core is open source, and then you provide some value add on top of it that you have to pay for.
Yeah, but what I learned when I was at Zero Turnaround is that selling software is very hard, while selling services like software as a service is much easier to start with. And that's how we end up deciding that our first product will be a SaaS product, because it's also the biggest pain of our community. Like they appreciate test containers, they like the model, but then they always come back to us and say, hey, like I'm having issues with Docker, or I cannot run Docker in my environment, or my Docker keeps getting updated and things get broken. So what should I do? And as an open source project, you don't have that many options. And we cannot even implement our own Docker because like that's a lot of work. But what we can do, we can just take this problem away from them, put it in our infrastructure. And by the way, due to the specifics, we aren't just a single data center somewhere in the middle of the United States, but in fact, we are an edge platform, so that we are bringing workloads close to the users because their test code stays on their machines. And that's a cool thing because, first of all, you don't need to change your existing tests. Like you just add Testcontainers Cloud to your existing Testcontainers test base. But also, you keep your test code, your original source code, and everything on your machine, and you only communicate with containers started on our platform. But obviously, for that to be efficient, we need to make sure that we aren't talking to data centers in the United States from Europe. This is why also for data privacy and other reasons, it's better to be local, and that's what we are doing.
And you can integrate this into whatever people are using for their CI system. So if people are on Jenkins, great. Just like throw the Testcontainers Cloud proxy into Jenkins and done. You don't have to think about how those resources get spun up or managed. But whatever CI system people are using, I guess I need to try the Testcontainers Cloud with like GitHub Actions, and I don't see any reason why it wouldn't work, but I haven't tried that yet. I'll have to give that a try.
I have some private beta users who've been doing that already, and what's cool about Testcontainers Cloud, the MVP, is that it unlocks so many possibilities. Like we were never thinking before. Like for example, running integration tests in parallel, because like if you would run your containers on the same machine as your tests, then containers most probably will consume 100% of CPU of your machine because they actually are heavyweight. And if you run your tests in parallel, then your CPU will always be shared between containers and the test, so they won't be as efficient. While if you move the workloads to some other machine, especially high performant hardware that is as close, like your Docker will be as close to the hardware as possible, as opposed to running virtualization Mac, for example. Then you can dedicate 100% of CPU to your tasks, or maybe not 100% of CPU. Maybe you want to scroll Twitter and read Facebook and do things while you're running tests. Why not? Because if previously you run your tests and then fans start spinning and you just wait for them to finish, now you aren't adding this load on your machine from containers because they're no longer on your machine. And
they're on
that's
a cloud
one way of doing it.
So let's say that you had 100 tests that you wanted to run isolated against in their own versions of Postgres or whatever, and you could run all those sequential, but that would take a long time. So now you can just say, all right, Testcontainers Cloud, spin up 100 instances of Postgres and run all of those in parallel, and those resources are no
So
longer being
each
used
test is running in its own instance.
Yeah.
Huh.
If you wanted isolation of your tests.
Well, isolation and speed, I would think.
Yeah. And some tests you do sequential, they have to be sequential. Like you're going to, add a row to a database and then do another test to make sure it's still there and all that. But in cases where you can't have isolation, run them in parallel and let the cloud spin up as many instances as you want to pay for.
So you said earlier that you were in a company, it got acquired, and that company was too big for you.
Mm-hmm.
And now you're starting your own company and you have 10 people. Mm-hmm. Have you thought about, I don't know, are you going to go with the normal hierarchical business structure? Or have you thought about, maybe doing something different so you don't get that too big feeling again?
Well, the cool thing about being a startup is that it can be like as agile as possible and as casual as possible. So currently, we don't have any hierarchy, and we just work alongside each other. And the hierarchies, I think, is something that should happen essentially, and not like being forced to happen. So if we see it some days that someone would want to see someone on top of them, just like as a proxy, so that you aren't reporting directly, but you get more structured feedback from someone like some decision maker, than like, let's say, engineers. The more we grow the engineering team, the more we have a need for engineering manager, like head of development, for example, head of engineering, because then if you get feedback directly from product owner, then you may not be ready for this feedback. This feedback may be too big for you because it includes some product vision, some strategy and everything. And you need someone who would proxy this feedback for you. You need someone who would ignore the product vision part, which is important for consideration, but not important for the implementation. And then would turn this knowledge into actionable items for you as an engineer. But we believe that when we will need it, then this will be a signal coming from the team versus something that comes from the management saying that we are introducing this manager between us and you just because we decided to do so. And of course, there will be scalability questions, like how to scale a team to, okay, currently we are 10 and it's manageable. Like when you have 10 people, it's basically a team, like a single team. But then more products you have, more people you have, like when you are, 30 engineers, it's impossible to manage them all at once, not to mention having direct reports. But that's something that we'll learn over time and we'll see.
It's interesting because the way you described the manager's job was more of an information filter guardian kind of thing. And you called him a decision maker, but you didn't actually describe any decisions other than being a filter, not telling people what to do, just helping them with
information processing.
Saying, okay, I'm going to say that I don't want to add that to their burden, this particular information, whereas this information they do need to know.
I think a lot of your organizational experience comes out of open source and how information kind of flows and is managed and scaled in open source. And I think that's influenced your perspective, that it's like, let's go to the level of what people need, and if people need an information filter, then you can put an information filter in place.
But they don't have to be a decision maker.
Well, but the engineers may say, we need somebody to make these decisions for us because we don't want to be responsible. I don't know if that's a reality or not, but I don't know. I guess
if the engineers want the hierarchy, yeah. I mean, basically that's it. That's what I encountered, is that you, just because you don't want the hierarchy doesn't necessarily mean that the people who are quote unquote under you don't want the hierarchy.
They may feel more comfortable with having
because that's what they know.
That's what they're used to.
Yes.
And our thinking about our own company definitely comes from our experiences of being engineers in teams and being employees and not like business owners, because it's our first time experience of running a business. And while both of us, Richard and I, we had an experience of running teams and working in fast growing startups, bootstrapping the teams and everything, we were still lacking this experience of just being like the owners of the business. And the best way to learn something is obviously, first of all, to learn from others' experiences, and also to kind of to think how would you like to see yourself, like if I were a developer in this team, would I be satisfied with me acting as CEO, or there is something that I would not be happy about? And you can like it's sometimes a balance between things that have to be done and things that can be avoided. And it's important to identify things that can be avoided when we talk about some maybe not negative aspects, but like aspects that reduce the productivity of the team. Because our biggest focus right now, and especially for me as a CEO, is to make sure that our team is productive, that we deliver, that we have everything we need to deliver what we want to deliver, and that includes clear understanding of what the goals are, why we are doing things. Not even how we are doing things, because first of all, we have Richard, our CTO, for that, but also we have an amazing, like a set of amazing engineers, like a team of amazing engineers in our team, and we trust them. We believe that if we let them be productive, then we'll see the return we expect.
And they work remotely, all of them?
Yes, we are a fully global Async First company, and we have team members in Germany, in Poland, in Estonia, one in Russia, in UK, and I'm in the United States, in New York.
Mm-hmm. And do you? I've sort of derailed this from the technical aspect. Do you have more technical questions you want to ask about?
I wanted to talk a little bit about like where you're at today. You have Testcontainers Cloud in private beta, and Testcontainers open source is still cruising along, and you all are investing in that and making it more awesome all the time. What else is exciting, or what's upcoming? What can you talk about that is on the horizon for Testcontainers?
I guess what changed for us when we started the company is that now there is an entity to reach out to, because previously it was just a group of people working on a project, and you cannot even establish a commercial partnership with them, because you cannot establish a commercial partnership with nothing.
Just an open
like you need
project,
to have this entity.
Yeah.
And when we started the company, we started getting some requests for partnership by vendors, by other companies who are doing similar things in our space of testing and others. And this is great to see, because now we have means of establishing, let's say, programs. So let's say we have modules for technologies, for databases, for Postgres, for Elasticsearch, for Kafka, and others. But these modules were mostly created by us, and then some contributions by the community. And sometimes you would be surprised, but like we were receiving some great contributions from the community for some commercial modules. So let's say Google Cloud module was contributed by external contributor who isn't working on Google Cloud, but who was using Google Cloud himself, and Edu. He is an active contributor to many open source projects, including a lot of Spring projects. But he was in Google Cloud, and he decided to contribute a module to make it easy to test Google Cloud services with test containers. But one would expect that this module would be the result of collaboration with Google Cloud, let's say. Or Elasticsearch module was being we received a lot of contributions from Elastic, like some of the folks at Elastic. And by the way, Testcontainers Golang is currently being co-maintained by an employee from Elastic who are using it extensively and contribute back by maintaining it. But it was never clear whether some of the modules are being maintained by the vendor or just by us. Because if it's a result of a collaboration with vendors, then you trust the module, right? Like you would know that this is exactly how vendor would do it with test containers. While if it's by us, then maybe some things won't be working, maybe we did something incorrectly. Because we, the test containers team, we have experience with many technologies, but with not all of them. And sometimes when people were requesting some modules to be added, we had to learn them first to implement them, which is a great experience for a software developer because we ended up knowing more technologies than an average developer would know because we had to integrate with all of them.
Yeah.
But it's still a knowledge to keep in your head. While what we can do now, we can establish this partnership. We can have vendors work with us directly on this vendor supported modules. I'm not talking about commercial support as in you can go to them, pay them, and then they'll fix your issue, but rather have someone from them uh, um, to work on the module together with us to make sure that their users, because we have a lot of database vendors who delegate testing of their technologies to us, such as Neo4j, Elasticsearch, Couchbase, Kafka, Apache Pulsar, and others, like a lot of them. They just recommend test containers when their users want to test their technologies. But now we can have them and we can gain this expertise from them and improve, sometimes even improve their technologies, their Docker images, let's say, to make them easier for testing. Because sometimes we apply certain optimizations to make them start faster. Because for testing, you don't need the persistence, let's say. You don't need to write to the file system if you can keep it in memory to make it faster because it's testing. And while currently we research these flags and we tune these internal settings, we could have something like development mode by the database. Imagine if every database would come with development mode so that you can start it fast in ephemeral state, but then you don't need to know how to configure it based on production configuration, but rather something for development. And some do provide that.
That's cool. Yeah, and the other thing I'm thinking of along these lines is I remember Mark Fleury, founder of JBoss, he at one point said that one of the biggest values, or maybe the biggest value of open source companies is their brand. And I was thinking about how maybe an opportunity is that with test containers, let's say that Confluent, let's say they found value in the test containers brand. If test containers could have a brand like organic, to use the organic brand, you have to have done a number of things and paid money or whatever. But what if Confluent could say, yes, we are test containers certified or whatever, and then they had to pay money and they had responsibilities in order to use that brand. But then you could be like, yes, like Confluent has a test container certified, test container or something would be an interesting option for those vendors.
This reminds me of the TCK by Oracle. And then if you want to have a certified Java version, then you need to pass the TCK, and to obtain it, you need to pay Oracle. That's something we may consider doing in the future, just as an addition to the platform really that we are building here, because test containers is the first step, but then we'll have many more. And our end goal would be to have test containers platform, just a go-to solution for developers and only for developers. Like we are a developer-only company. Like we focus on developers because that's what matters the most for us, and we believe there is a great opportunity there. But we want to make sure that every time a developer needs to test their code, then we'll provide them all the tools they need to make it easy, to make it fast, and to not think about the question, how do I test, but rather focus on writing the test and then getting it green and making sure that it has the correct thing.
Yeah. Integration testing as a service. Remember, and that was like the hot thing, is like everybody wanted to be something as a service. Yeah.
It's not anymore.
Well, now it's serverless. So serverless integration testing. That's the
as a service. I thought as a service was still kind of a thing.
But it's, we went through the phase of like Uber, but for so AtomicJar, it's Uber, but for integration tests. That doesn't work at all.
No, Uber just
whatever that means.
Uber's kind of got a stain on it.
Yeah.
Yes.
They've been washing that stain off. It's getting better.
So you abuse people as a service.
Ouch.
Abuse as a service. Okay.
But jokes aside, like 10 years ago, the majority of testing was done with Selenium and browser testing and QA teams automating browsers with Selenium. And when you think about it, test containers to Docker is what Selenium to browsers, because you have browsers as a way of opening web pages. Then you have Selenium to control the web pages. And basically, test containers becomes Sauce Labs and Browser Stack and others for Selenium. We just take these browsers from your machine, because then you're no longer, like, when you run Selenium tests on your machine, then you need your browser to be open, so you're not productive. While if you can move these browsers to the cloud, then not only we can run it with some exotic browsers such as Internet Explorer that we cannot run on macOS, but it's a similar thing here. But now that we focus on developers, now that we shifted to the left, then we also talk about the idea of developers being the ones who test. And developers are different species. They aren't using the same tools. They aren't doing browser testing. They need something that is close to what they need to do. And integration testing is a sweet spot, because then they understand how to perform it, and they need new tools, and test containers is the tool here.
Yeah, I think this is bearing the lead. That's what you need to start with. Test containers is to Docker as Selenium is to the browser.
Yeah, it's a good way.
That kind of is a good starting point.
Yeah. So one other topic I wanted to hit on to wrap up was that I love using test containers for things that are like open source services. The one gap that I run into is when I am integrating with a SaaS platform like GitHub or Salesforce or whatever it may be. And that's the place where my integration tests still need to talk to the real service, because there is no like GitHub. Like I can't like call the GitHub APIs or get a webhook call like without using the like real production SaaS service. And so I hope that in like 5 years, somehow we're able to like test containerize even those SaaS services in some way.
So you could clone GitHub to your local machine.
Yeah, like somehow GitHub ships with a container that is API compatible with GitHub, but is not production GitHub, as an example. And like you could maybe do this through like mocking their API. Like I've seen some attempts to like record API calls and then create a service interface that is based on what it saw in the past or something like that. But
so how do you do that? Like if I create, say, a database, and then there's the test container for the database, and I make some change, what keeps the test container in sync with the change? Is there any tooling to make sure that, or make that happen automatically?
So when you're writing your integration tests, you will just have your like schema set up, and then you'll have some way to bootstrap your test data or something into the database. So usually when you write your test, you'll say, here is the setup that I need so that then I can run my test. And as part of that setup, you will define all of the pieces that need to go into your database.
That's you as a user.
As an integration test developer.
Right. I'm talking about from their standpoint. So, here's a tool that has been adapted for test containers, and then they change their API. And do they have to just go by hand and fix the test container?
Oh, I think I understand the question.
Okay.
Like, how do we keep our definitions up to date with the evolution of the underlying technologies? Right. And that's actually a good question, because that's day two experience for testing library, how to keep it in sync with the underlying technology. And while we got lucky with most of the modules that we had that did not require a change in what we do, because we operate on this level of abstraction of Docker. And most of the times their Docker images are compatible, because like that's the same way how we start them. The command is implicit, so we don't need to know it, most probably. in some cases, we actually had to add some level of compatibility with both versions. And there were some minor cases where we just like a different environment variable we need to set, and then we can just set both because they won't be failing if both are set. But sometimes you also need to go as deep as understanding what the version of the image is, and then depending on the version you would do different actions. And that's actually the cool thing about test containers being programmatic, being a library versus a tool. Because if you had some tool, let's say Docker Compose, then there's nothing you can do because you have this declarative YAML file, and everyone loves YAML, of course. And then like you cannot just do conditional logic based on the image that is being used.
Right.
And also, Docker Compose knows nothing about the underlying technology, nor it is testing oriented. It's general purpose solution, and we are focused on testing, so we can assume things. But in test containers, we can, for example, check the version of the image that is being used, and then if it is compatible with version 3 of some database, then we do X. If it's compatible with version 4, we do Y. And then this is all part of the startup like pre-configuration that we can do in programmatic way. And then we just have this if else. So that's how we keep them compatible with the evolutions.
Sometimes the container abstraction is leaking something through that then you have to deal with. But thankfully in test containers, you have the opportunity to deal with that because you've got the programmatic logic that is controlling the container and its inputs. And
it all sounds very smart and at a good level of abstraction. Could you create a build tool now?
Yeah, that's right. Please solve the build tool problem next.
Something to replace Gradle with, please.
Yeah.
Yeah, but to compensate that, I also should mention that we weren't always smart about what we do, because sometimes we managed to leak some of the implementation details, something that we start doing, for example, for local stack, one of the most popular modules for test containers, we were exposing AWS SDK classes. And then what happened is AWS SDK released version 2, where they changed the package, changed some implementation details. And now you literally have to bring AWS SDK version 1 on your class path just so that it can start. And while it's very unfortunate, we also care a lot about backward compatibility of test containers. I've seen people migrating from test containers 1.4.2, which is 4 years old, I think, or 5 years old. 4 years old. To the latest and greatest just by changing a version in their build file and nothing else. And luckily, we had this expertise of how to keep things backward compatible. But now that we have this promise and we want to keep the promise, we cannot just remove some method because it exposes AWS SDK just because we want to support, we want to get rid of it. But what we always do, we always make it so that it works with the newer version of the SDK. Just, yes, okay, unfortunately, you have to keep this dependency because that's how it was. But every new module that we create, we set it as a rule that we never expose third-party types to our public API. Yeah. And there is also this most famous thing about our API is that we depend directly on JUnit 4. Because when test containers started 6 years ago, JUnit 4 was the solution for running tests. And while this dependency is optional, if you think about it, you can start test containers by just doing something like new Kafka container, kafka.start. You don't need JUnit rules for that. You don't need anything from JUnit. You still have to have JUnit 4 on your class path because we extend directly from one of JUnit classes. And that's unfortunate. I understand that. We understand that very, very well. And we have integration with JUnit 5. There is integration with CodeTest, with Scala test, and with spec something for Scala spec 2.
Spec 2, yeah.
But you still have to have JUnit 4 on your class path. This is why we are working on a new version of our DSL, of our APIs that would not require JUnit at all. That would be JUnit free, #JUnit free. And it will solve some other things like recursive generics and others. But that's the result of 6 years of working on an API for testing. And every time I hear about someone considering just, like doing something like task containers, but from scratch, or, why don't you just do it with Kubernetes? Then I only have a smile on my face, because I've been there, done that, and I understand what
tried and learn your lessons. And
yes, what will be next for them, like the issues they will hit next, which also gives us an advantage as a library, because we are so ahead with all these things. But we always improve. But we're always improving.
Awesome.
Great.
All right. Well, we will wrap up on that. But Sergei, thank you so much. So good to learn about test containers. Thank you for making the world of integration testing better. And for those of the listeners that haven't tried test containers or AtomicJar's Testcontainers Cloud yet, it's in private beta, the Testcontainers Cloud. So you can reach out via the AtomicJar website and give it a try. It's amazing.
Yes. Thank you.
James.
Thanks, Sergei.